So what you guys are doing today is 4.3a, 4.3b, more or less just working with rational expressions and then equations in part B. Um, so just do this warm-up, take a couple minutes, simplify the following, pause the video, and then once you're done, just resume it. All right, so I asked you to simplify these, but a couple of them are trick questions because what I want you to see is when you have numerators and denominators with multiple terms in the numerator, you need to look for what they all have in common. So if you look at these, neither of these three terms have anything in common, right? These two have something in common, these two do, but in terms of all three, none of them have the same exact thing in common. These two have y's, these two have x's, these two have 3, but they don't have anything in common. So this is fine. I would take that completely as a final answer, simplified, whatever you do with it. And if you look at number 4, it's the same thing. Neither of those things have anything all in common, so that's fine. You could break it up, give this one a denominator of negative xy, give this one a denominator of negative xy, and then break it up from there. Same thing with here, this part over xy, this part over xy, but it's not more simplified than one, so that's fine. Number 2, they all have 5 in common, so you can reduce it all by 5, and then you would just get x squared plus 2 over 1, which is just x squared plus 2. And then this one, they all have 2 in common, so you could divide them all by 2. You get negative 1 plus or minus 4i over negative 2, which you could even divide them all by negative 1, and then you would get 1 over the 2, and then if you divided plus or minus 4i by negative 1 or multiplied it by negative 1, I guess it would go from plus minus to minus plus, but it's the same thing. You're kind of covered on both parts. So you could just leave it like that too. But I don't want you to think that these two negatives canceled because they really don't. Again, you're looking for all three things to take out of the same thing, which in this case is fine. All right, so part 1 of this whole thing is radicals. So when we do radicals, we've kind of already done it before. Again, just a little bit more of working with fractions, but here and here and here, the problems are when you would break it up, you'd have third root 2 over third root 3, which is a problem because you can't have a radical in the denominator, so you need to rationalize it. So if you multiply it by third root 3 over third root 3, it wouldn't solve your problem because you'd have third root 9 in the denominator, which is still not perfect. So if you're at 3, right, you want to think of what can I multiply it by so that I get a perfect third root? Well, if you're at 3, a perfect third root is 27. So if you multiply it by third root 9 over the third root of 9, which is the same thing as 1, so you're not changing the value of anything, you can get an answer of third root 18 over third root 27, which the third root of 27 is 3. Okay, so now do these other two ones on your own. I'm going to put up the answers in a second. All right, so if you did the second one, just have the answers mostly here. You can kind of see the work here. So I simplified third root of 32 right away into 2 third root 4. Here, third root of 5x. Well, if you think about third root of 5, if I multiply it by third root 25, I get the third root of 125, which is 5. Third root x times third root x squared will give me third root x to the third, which is just x. Right? So that's kind of how you want to think about simplifying those. Same thing here, fourth root of 2. Well, if I'm at 2, I want to get to 16 because the fourth root of 16 is perfect, which is 2. So I said 2 times what will give me 16? 8. I already had c to the third, so all I need to do is multiply it by another c to the first. I'll get the fourth root of c to the fourth, which is just c. So you can see the answers there. All right, so go ahead and pause the video again. You can do this in partners, but you can certainly do it on your own. If you want to consult some of the people around you, you can, but I'll just give you the answer in a minute. All right, so this one, kind of more of the same. The thing about this one is I gave you 9z to the third. So if you think about you were at 9, basically all you needed to do is multiply it by another 9. You get the 4th root of 81, which is just 3. You could have done 9 times 9 times 9 and gotten it a little harder, but if you could see that 3 squared was 9, you just need to multiply it by another 3 squared to get 3 to the 4th, and then the 4th root of that is 3. So that would be your answer for that one. All right, so complex fractions, which is really the key part of today's stuff, is basically you have a fraction, and then you have fractions within the numerator and/or denominator. So if you have to rationalize this, basically what you want to do, step 1, is get it so that there's only one fraction in the numerator and one fraction in the denominator. So here I have 2 over a plus 3 over b. I want to get this so it's just one fraction. So what I'm going to do, this part will show it over here, is this is just the numerator, but if I multiply the numerator, I can multiply the left side by b over b, and the right side by a over a. And all that that's going to do is make my denominator ba, right, ba, so I'm going to have 2b over ba plus 3a over ba, but I can do that, right, because they have the same denominator, ab, ba, same thing. So that's going to simplify to 2b plus 3a all over ab, right? I no longer have two fractions in the numerator, I only have one fraction in the numerator. And the denominator is going to work the same way. If I do a squared over a squared, same thing as 1, so I can do it. And then times the right side by b over b, I will have 5a squared minus 6b all over a squared b. Okay, so again, two fractions, now it's only one fraction. And then basically step 2 is you're just going to take those, and instead of trying to divide, think of it as multiplying by the reciprocal. So this was my reduced numerator. This is the reciprocal of my reduced denominator. So instead of dividing, I'm multiplying by the reciprocal. And then you get your answer if you just multiply through. Didn't even multiply through, actually. They just kind of kept it in that form, which is actually better because from here you can see what cancels, right? So I have an a, which would cancel with one of the a's, a b, which would cancel with one of the b's, and that would be your final answer, right? Step 3 is just to simplify, which is what we just did. So final answer is 2b plus 3a, and actually I'd have to distribute this a through, so I'm going to say 2ab plus 3a squared all over 5a squared minus 6b, and that's it. That's a 6. So you can't cancel this a squared with this a squared for the same reason as the warm-up. You'd have to look at if all 4 terms have something in common, then go ahead, but all 4 terms don't have anything in common, right? These 3 have a's, but this one doesn't. Right? These 2 have b's, but these 2 don't, so you're good. All right, so again, in your groups, or if you just want to do it on your own, just try and do these 2 problems so you can pause the video, and when you finish, get back to it. And if you did finish, just give you the answers here. These would be your 2 answers. So you have 3x minus 14 over 5x minus 16, and x minus 1 over x plus 1. You can pause the video if you want to look at all the work in case you didn't have that. And then the last note here is just if you have things like this, right, this is not a complex fraction, it's just one numerator, one denominator. But anytime you see that, look to factor things out to simplify. So the numerator simplifies to x minus 5 and x plus 3. And your denominator simplifies to x plus 3, x minus 3, right? Just conjugates, difference of squares. So what you see are the x plus 3's would cancel, right? So you have x minus 5 over x minus 3, which should be a simplified version of this, right? Now, there is a little bit of an issue here, though, because this is not the exact same thing as this. So in simplifying, we changed it a little bit, which it shouldn't be, right? And the only difference is here, if I looked at this, I would say that I could probably plug in the number negative 3, right? Because I couldn't plug in 3, and I know that from looking at it, because if I plug in 3, I get 0 in the denominator. But if I plug in negative 3, my denominator is negative 6, which is okay. But if I look at the original, I could have never plugged in negative 3 right there, because it would give me 0 in the denominator. But here I can't tell that. So after your answer, you have to put a little comma and just say, oh, by the way, x cannot equal negative 3. And just by saying that one little statement, this whole thing is now the exact same thing as the original, right? So just by adding that one little piece of information, it is now a simplified version of this. So you do need to include that, something I do take off points for. So basically anytime you're crossing these things out, you can throw in the fact, oh yeah, I need to account for that in my final answer, okay? All right, so that's it for 4.3a. The next video is going to be on 4.3b, which is just doing these things but with equations instead of just simplifying expressions.